Hey guys, what's up? So in this video we'll be seeing how to create a simple HTTPS web server using C#. Resource URL will only have the path to the resource. Okay, for example, uh, let's say you are making a request https://localhost.com. Just any domain would do, and then say some page.html. The resource URL is nothing slash some page.html. Okay, now we have to prefix it with the www path, that is the actual path or the root folder for our server. Okay, so we will prepare it string actual path and then we will be appending it. Okay, int response code is equal to 200, assuming the file is there. If the file is not present, we will change it to 404. We will be just creating an output payload bytes array. We will be populating it. Also, we have to identify the file type so that we can put the corresponding content type in the response header. The resource URL equal to null. Now the actual path is equal to slash index.html in case if it is empty. Okay. Else if resource URL dot equals, sorry, it's actually ends with this. For example, he can also ask, the user can actually stop the request with a slash that actually indicates some slash index.html, which means wherever be the root directory is slash some slash index.html is the actual path in that case. So if the request URL ends with this, that means actual path plus equals resource URL dot trim. Okay, I missed to trim it here, so that trim plus, else whatever path he asked for is exactly the actual path. If file.exist of actual path, okay, this is where we have to give a 404 if the file doesn't exist. Now we will determine the file type using the index of dot, that is assuming the file name ends with a dot as suggested by Visual Studio. So we should make it last index of, because we don't want the first index, because file name extension will be towards the end, so we can ignore any dots in between. We will go for the last dot to identify the file type. Now we have to get the file type, so we have to define a dictionary where we can map some extensions to some non-file types. We will do it in a moment. Before that, we can say output payload is equal to fetch file content. We can just use the fetch file content by giving the actual file path, so we'll get the bytes array from the actual file content. So we have already defined that function here, which will be directly reading the files and the gets the bytes from the file and fully return it as a bytes array. So we have it here. If not, response code will be set to 404 and output payload should be equal to. So now we don't have such a file in existence. So we have to prepare our own HTML body saying that it's a 404. Okay. Here we'll say HTML. Now we'll just, this is for styling and all. You can just modify it the way you want, or you can actually write a 404 page and then put that as the actual file path and get the bytes from that file. For the simplicity's sake, I'm just going ahead and typing out the HTML code directly here. So this will be the output payload, or else the actual file content will be the output payload. And assuming that we will be doing this to do file type here, I'll just keep a to do there. I will do it in a moment because we need to define a dictionary for that. File type is equal to, so if the file type is null, we will just assign it with text slash plain followed by char set equal to UTF-8. It's a shorthand way of checking whether a variable is null. Here I, instead of putting it as null, it's an empty string, so that check will never get in. So I'll just put it string, nullable string, and then I will assign it to null. Okay, so if it is null, then it will actually set this value, or else we will be assigning the value here. If the value was not assigned, we will assume it's just text slash plain. Now we can define a bytes array for header bytes encoding dot ASCII dot get bytes. Here we'll call our method HTTP header to which we'll pass the response code and the content type, which is nothing actually our file type, and then the content length. Content length is nothing, whatever is the output payload. Okay, content length is the length of the body. We don't have to include the header size in that. We'll +1 and we will add a new line also to the body. Okay, just to indicate the end, nothing else. Length dot one. So that is the output payload length +1. And also we'll say bytes, we'll put a byte array end connect, just putting a new line here. It does actually nothing, but still putting a new line here. We missed to close one bracket here. Yeah, here I will just put a single new line. That is the reason why I added +1 over here, so that the actual payload will be the content of the file. Then I'm just adding an additional new line here. Doesn't make any difference, but just for the sake, I'm just adding it here and then adding 1 to the length of the payload. That is technically the payload length of the output payload and the connect. Okay, now if stream, the SSL stream, if it is not null, then we can write this data into that. All you have to do is SSL stream dot write header bytes. Then you can just pretty much copy this line 3 times and change it with the output payload, and then end connect. That is the new line. Like I mentioned before, this line is not mandatory. You can just feel free to skip this and also just remove the +1 from here. If you're adding this line, make sure you give a +1, or else go ahead and skip that. And SSL stream dot flush. And with that, we are done. We just give a return. I think with this we are pretty much done. So we now, okay, we have to extract the file content. I actually missed to do that. No issues. We will define a dictionary here which will map the file extension to file types. You can keep on adding the extensions and file types as and when needed. For the simplicity's sake, I am just using a bunch of types. So here I have some non-extensions that I kept it here. Okay, I'll just copy it, and now I'll go ahead and create private iDictionary, which will be having string, string, file types, new dictionary, and then followed by braces so that we can define values while creation, and then we can just simply paste it. So if the extension is text, this is the content type. For images, I'm putting these, and for the HTML, I'm putting these. For JSON, I'm putting these. XML, I'm putting these. You can keep adding to it. Now we'll go over here. We have the file types dictionary. Then we put substring starting from the index of dot. And it's all under an assumption nothing is gonna go or crash or give us empty. Okay, it's not foolproof code. I'm just saying it as an example and going ahead. Okay, there will be too many optimizations like how to extract the exact resource name, things like that. I'm not caring about the string operations, things like that. I'm just going ahead and doing it whatever is coming into my mind right now and finishing it off. That's it. The optimization is up to you. So I think we are done. We just have to implement this method, which will print out basic details about the stream and the incoming connection. And if any exceptions, we have already logged it here. And I don't think we missed defining any functions, and the number of errors is 0. So I think we are good to go. We'll give it a shot. If some error happens, we'll see it during that time. Okay, now we'll just go ahead and print out some certificate and stream related information here. For this, I have already prepared it and kept, so I'm just copy pasting it so that I don't have to waste your time. It's nothing. You have the client object. You can just see whether it's connected or not, receive timeout, send timeout, buffer size, things like that. We are not using it anywhere. We can use it if needed, but I'm just printing out some information. Also, we can print out some other information about the security level and things of the SSL stream as well. So this thing is also something I'm gonna copy paste because I have already prepared it and kept. So we have the stream. I'll just rename it to stream variable because in the previous example which I was trying it out, I named it stream itself. So that's why we are seeing it, because to be honest, I had already tried those things before trying to record this video. Okay, so I have all those things handy, so I don't want to redo this thing because it's just printing out some information related to the stream, and there is nothing much to explain. I'm just putting whether it's authenticated, is signed, is encrypted, mutually authenticated. For example, when I mentioned we don't have to, while authenticating as a server, there was a parameter called client certificate required. We set it to false. If that is set to true, that means client also has to provide a certificate. That time is mutually authenticated will be becoming true. In our case, it will be mostly false. And there are 2, 3 other parameters like this, whether this stream can be read, whether this stream can be used for writing, and whether the stream can actually time out. Yeah, it can obviously time out because even the even if we are not setting the timeout, definitely the browser is going to close the connection after 60 seconds or 120 seconds depending on the standard. And I'm going to leave this cache as empty. So we have pretty much everything that is needed for logging. With this, we'll go ahead and try to start or spin up the server. And one thing I have to say is whenever we are using this SSL server, there are too many errors related to the certificates, things that you are going to encounter because SSL is, to be honest, much more complex than we think than plain HTTP servers, things like that. So HTTP protocol as such looks simple and easy and straightforward to deal with, but when it comes to SSL, it's a bit tedious, like there are too much of algorithms involved, too much of security things involved. So we are going to get a lot of errors. We can use these all resources to debug it. But of course, I would prefer using a standard client like curl at first while debugging, because curl with verbose output can provide you a lot of information on exactly what's happening during the handshake, SSL handshake, things like that. And also I have a Wireshark capture which is enabled on TCP port 443, and in order to capture you can go to options and then look out for loopback interfaces, because in Linux we have the localhost interface as such for the loopback. On Windows we don't have it, but when you install Wireshark and encap, this particular adapter for loopback traffic capture will be there and you have to capture on this particular one. And I'm just filtering it on 443. You can filter it on any port that you are running your server with. Okay, I'm not starting the capture yet. I'm just telling so that I can demonstrate how things are actually working underneath the hood. And when using a curl, make sure you are using the command prompt of Windows instead of PowerShell, because this curl on command prompt looks like pretty much similar with the Linux version of it. So you can use all the arguments there. For example, -v for verbose, -x for specifying the method type. We only support the method type get. Now another thing is here, whichever certificate I generated is for some website called mylocalhost.com. So for the tutorial purpose, I generated the SSL certificate for this particular domain, mylocalhost.com, and I want it to be mapped to this IP. So I'm just adding it in host file so that whenever I try to access this website, its traffic will be given to the loopback or the 127.0.0.1. In Windows, if you don't know where it is exactly is, you can just go to C drive, Windows, System32 drivers, and etc, and just change it to all files and you will find the particular file. And then you can add your domain here and map it to the loopback IP, so that when we are using it our browser will not be throwing SNI errors, things like that. For the time being, just add whichever domain you are planning to use here, or you can go ahead and use the 127.0.0.1 as well, no issues. For the sake of simplicity, I'm using this to avoid other SSL related errors. Here, if I go to the certificate and open it, and if I show you the certificate details, you can see it's issued to mylocalhost.com. That is the reason why I added that domain there, so that I can use that domain instead of using 127.0.0.1 to avoid one error with the SSL. Anyway, as it's a self-signed certificate, the SSL errors will be coming. I'll be first demonstrating the things using curl. So here I'll say https followed by mylocalhost.com, and then give --insecure flag, so that curl will not be validating the SSL certificates, things like that. And if you are using any other port instead of 443, just mention the port over here. For the time being, I am using standard 443 itself as the port, and I'll say index.html. We'll see whether if it works or not. I'll start my server. Okay, now we haven't implemented the stop server button yet, but that's fine. Okay, you can see the certificate got loaded and the certificate serial number is printed over here. In order to just validate, you can open the certificate and go to the certificate details, and you can see that is the serial number which we are seeing on the text. This number is same as that number. Okay, after all, it's just logs, so you don't have to worry. Now we will go ahead and do a call. Okay, something happened. I don't know what happened. it got resolved to 127.0.0.1, but unfortunately our server was not listening there. So here I'll go over here to the TCP listener. 443 is the port, and we have the, okay, my bad. So I forgot to start the thread dot start. My bad. Okay, and start the server again. And yeah, this time, yes, that's just a Windows prompt. We don't have to worry about it. Now we'll go ahead and execute this curl query. And you can see successfully we got the HTML header. And yeah, this is the header that we set. And you can see its type is text/HTML, things like that. And also now I think I have a file about.html. Okay, so we have to make a small modification or slight modification here. While true, we process the stream, and then we will come and again listen on the connection. Okay, that looks good to me. We'll start the server again. So we got the about page as well. Now if we do this, we should be getting the connection again. Okay, let's see whether we are getting an incoming request. Yeah, we got a request, but we are not processing it. So we have something wrong with the logic that we are using. So in between, I paused the recording and I went for debugging what exactly happened. The funny thing that happened was in this method, we were setting this thing that is reading details to false so that we can prevent the closing of stream and client if the UI thread is writing it into the text file. And after writing, the UI thread should set this variable back to true, which we missed or I missed. That's the reason it was hanging here and preventing this from closing. Hence, the thread was not completing and it won't be accepting any other new connections. So now we can go ahead, start the server, and then we can open the command prompt and we can just go ahead, query n number of times. We will get that many requests, and we can go ahead and do something slash data.json. And you can see we got the JSON content, and also the content type was set to application/JSON, and also the payload length is properly set here. Now we can go ahead and try it with a browser. So in order to try it with a browser, we have to use the Chrome with SSL security disabled. Okay. And meanwhile, we can go ahead and start capturing on this particular port, continue without saving, and then can go ahead and make a request and see that the curl sends a client hello. That is the first part of the TLS handshake. So first a TCP SYN occurs, then a SYNACK, and then an acknowledgement. That is the TCP handshake. And now the SSL part kicks in. The client sends a hello. That is the curl sends a hello. Okay, that is called the client hello message. Server sends a hello with all the cipher suits, things that it supports, all the information for the SSL handshake to complete. For example, it will say the version supported is 1.2, things like that. The message type is server hello, and other additional stuffs required for the SSL session to be established. And once that is completed, you can see all the data is encrypted as application data. You can see it's application data, it's encrypted, and it's hypertext transfer protocol. That is nothing HTTP. Now let's open a browser and try using the browser and see what happens. So now I'll do http mylocalhost.com/index.html. So you can see the first connection will be failed because of this invalid certificate authority. Go ahead, proceed. Now it will make another request, and you can see the page is served, and we can see the certificate and its details here. For example, it's for this, and it's issued by SnatchStream CA. That is something that I created. It's a self-signed certificate for the tutorial purpose. Okay, and other things, everything can be validated from here. Okay, and you can pretty much go through all the. Okay, even you can go ahead, go to images and server.jpg. was the extension, I guess. Yeah, you can see the image is loaded, and meanwhile you could see how the TLS handshake happens for each request that is going in and out, and there will be exceptions. And if we go to the server logs, okay, you have to go down, you will be seeing some or the other exceptions that are happening. See, unknown error occurred. So some SSL connections will not even get accomplished. That is the reason why we are listening for multiple TCP incoming connections in a loop, so that if one fails, the browser will compromise on things and send back a request again. Okay. And like I mentioned, so whenever an error occurs, that TCP connection gets closed because browser will try to use everything possible, and sometimes our server will fail to meet some requirements. That specific TCP connection gets lost. Now we will be again listening as we are in a loop. We will be listening on the next incoming TCP request or the TCP connection. Once it's established, the browser will try to negotiate with a lesser parameters in the SSL because it knows the certificate is not valid, and it prompted the user, and the user was agreeing to take the risk of accepting that certificate and proceeding ahead. So things like that will happen. So some TCP requests are gonna fail, but the next one is gonna succeed. For example, now you can see we are using TLS version 1.3. This is the cipher we are using. This is the strength. This is the strength of the hash. I don't know why it's returning 0. And you can see there is another error. So for each incoming connection, there will be some or the other errors. Okay. And now we can just go ahead, clear, and then we'll go to the browser, and then we will go and access something that is very lightweight. For example, about.html. Okay. You can see the TCP socket gets established, then the client hello, then the server sends this, and you can see the TCP connection got closed. So I think it's initiated by the client. For example, the client will be using this as the port, and server is obviously running on 443. You can see the termination was initiated by the client. You will be able to see what exactly happened, things like that, by just looking at this a Wireshark capture, and we'll go get to know the exact sequence. First, the TCP handshake happens and a bare-bone TCP socket is created, which is plain unencrypted, then over which an SSL layer comes in, that is the TLS part. Client hello, server hello, things like that will be happening, and then finally once the server and client agrees upon a particular protocol, we are all good to go. Then things will be encrypted. That is the reason why Wireshark is not able to show the actual payload. Instead, it says this is the payload that is being sent and it's being encrypted. So unless we have the keys, we don't get to know. And then you can go ahead and do something like not.html. This file doesn't exist. So oops, you can see the 404 content came in, but something else happened. I think we have to. So we have the output body. That is because when the file is not found, the file type will be null, and it will be given a file type as text-plain. We have to change it. In case of an error, we have to make it text/html, and we will stop and rerun the server. We will start the server. We'll go to the browser and refresh it. Now you can see, oops, not found, because the file type was not set in this case, and it was by default set to text/plain. That is the reason we were getting this as the no page found. Now if you go to the view source, you will see the exact content that we were printing it. Now we'll go ahead and finish off the project by doing the stop server button. Okay, now in order to stop the server, we have to make this variable available globally. So for doing that, I'll just cut it from here and go to the top. And also I'll create a volatile variable so that I can use it to control the infinite loop in the thread, which is set to true. Now whenever we click the start server button dot enable equals false, and stop server dot enable equals true. So we are just making sure we are disabling the start button so that nobody will be clicking it again, and the stop button we are enabling it so that people can stop the server. Okay, and just copy these two lines. We can go ahead and paste it here and then change it true and make it false. Now to the while loop we can just add to keep this thread alive, and also over here we can do TCP listener dot stop, and also do keep alive is equal to false. Okay, now in case if an exception occurs while closing it, things like that, we'll just make sure we use a try catch to handle it gracefully. Just leaving the catch block empty. The same I'm gonna do here, because when we are stopping, and I'm gonna leave it empty. So when the button is clicked, we will be setting the button enable disable accordingly, and then we will set this boolean variable to false so that the while loop will exit and the thread will come to a stop. And before that we are gonna stop the TCP listener as well. In case of an exception, we are handling it gracefully. That's it. So we can stop and rerun, and here we go. When we press start, you can see that button got disabled, and we can go ahead, make a query here. You can see that it's serving the request properly, things like that. Okay, you can open up a browser. So now over here / my local host.com/index.html. So you can see it's working properly. Okay, we can go ahead and stop it, and if I refresh, it's gone. Yeah, now we can start the server again. I think I missed to. Okay, yeah, that's what. So when we start it again, we will be setting this to true, because or else it will never enter this while loop. So we'll stop and start it again. And now if you go ahead and start the server, we'll go to the curl, and you can see it's serving the request properly any number of times you want, and you can stop the server. You can see it timing out. Okay, now we can go ahead and start the server again. You can see it starts the server back and starts serving the request. And also it's the same on the browser. If you go ahead and refresh, it should serve it. Yeah, we are good. So that's it with the coding part of the SSL server in C#. Hope you guys enjoyed this video. Thanks for watching. Don't forget to like and subscribe. Thank you. If you learned something new, please give me a thumbs up. Please subscribe to the channel. Thanks for watching. Thank you.